But let me get started by giving you a number of some numbers here to show what we've heard before. Why is recycling and the recycling volume relatively low? Well, it's because we extract resources massively. If you look at 1990 to 2017, the resource extraction increased by more than a factor of 2. And disproportionately, also the growth of population figures has also happened. Now, what that means with a view to the year 2100, you might expect that almost 5 billion people will be living alone in Africa who also want to consume resources. So we're seeing the need for a trend reversal because we cannot continue the linear business as usual with 190 billion tons. We need to limit the resource consumption of 60 billion tons per year. Now, how can that be done? What you see here is refers to the context of yesterday, climate neutral business, and especially when we talk about resource consumption. So the extraction and processing of national resources causes about 50% of greenhouse gas emissions, but also contributes to 90% of biodiversity loss and causes 90% of global water scarcity. Now, this is the relationship really between resource consumption and at the same time the urgent necessity of the circular economy, because there are many other developments that will have on our ecosystems, mostly negative, of course. So what can design do? And this is what I'm going to talk about. Design for recycling is a central philosophy, but it's not the only one. This is not the only way how design can make a difference. It can work on a number of strategies to decouple resource consumption and the environment. I'll give you a few examples on design for recycling in just a moment. We need to increase efficiencies in everything we do. But if we have time for some Q&A, I will talk about self-sufficiency in lifestyles, and there are some good examples for that as well. Now, here's a specific example from a research project that has been completed just recently, Circular by Design. We looked at cooling and the challenges that entails. What's the current economic structure in the cooling business, if you will? If you use a conventional refrigerator that every one of us is using in their kitchen, and how could you make the design circular and the business models as well? Now, we didn't do that on our own, fortunately. We had a number of stakeholders along the value chain, including producers, or OEMs, retailers, all the way to the recycling business at the end of that chain. If you look at the fridge, the refrigerator, and that goes back to what colleagues have said before, we are using different materials, compound materials, mixes, different metallic alloys. They're designed in such a way that they're not really easy to recycle because they're connected to each other. So you have to design them differently. Otherwise, recycling is going to be very hard. Not enough has been done in terms of information and recycling. So in order to make it possible to tear down the products in an efficient way. And this is also borne out in product development. Now, this is what a fridge looks like. On the very left, that comes from the noughties until 2010 and then 2019. So this already tells you how complex a refrigerator, a modern refrigerator, has become, and how many added functions a fridge has. And what this also means, new modules, composite materials that are also used in them, which means that at the end of the chain, it's going to be very hard to reuse them or recycle them. And this also we did in an experimental project, and then we realized that there is a potentially central challenge, especially when it comes to existing data. What do recycling contractors know about a refrigerator that they receive? Now, unfortunately, they know very little. So therefore, the recycling routes have not been established at all for the disassembly or removal of materials. Design for recycling includes a number of conflicting interests. Design for repair is also one. So I think recycling contractors will need to see what they do. Do I just take a compressor out and then take the compressor apart? Or should you reuse an existing compressor in a new fridge as a valuable material? Well, in that context, your recycling process will have to be quite different. And that's one of the central challenges that we've seen.
Right, so we're not going to look at the product level. As before, we could learn it's not only about the product, but it's about the result of the service unit behind it. So the cooling in this case, and we need an interaction of applied implementation ideas that you can do very quickly and easily. For instance, the digital product path connected with the refrigerator to get feedback on the refrigerator energy consumption and so on and so forth, connected with a modular system. And we also need the speculative area. So the question is, do we really all need a refrigerator in our kitchens? Or maybe do you need a second refrigerator? Or couldn't we refrigerate in another manner? But I'll get back to that in a moment. Now, when it comes to the speculation, to translate this into a business model idea. So let's say we have a cooling box where you can get via your smartphone information on this unit. You'll get the information, everything's ready. You can pick up whatever you need. It would be better to not buy it, but you have to buy fermented food. So not food that needs to be refrigerated in the first place, but also an intensification of the refrigeration area in cooperation with local supermarkets, keeping in mind the logistics. This is an idea where you don't buy a refrigerator, but where you lease a cooling or refrigerating space. You no longer have your own. Of course, it's a bit of a conflict. If you get home and you don't have your own refrigerator around the corner, then it's something to get used to. But maybe this can replace a second refrigerator that you would otherwise buy. Regarding other applied systems, we used our results and said we have a major problem in the recycling routes. It's not the design that's coordinated to the information flows, the recycling routes at the end. What would help? And we arrived at this result. So the refrigerating unit and the cabinet unit, so to speak, should be separated. That's one of the central design ideas by my colleague, Christoph Kochtop. He says, well, the technology and the insulation should be separated from the actual cabinet part. A modular setup and adjust the recycling routes accordingly. And the cabinet, I mean, you could say I want a bigger cabinet or a new design because I'm moving to somewhere else and I don't have to exchange the whole refrigerator, but I just need to replace the cabinet, the external part of the refrigerator. And on the upper right-hand side, this is what this would look like. So in the middle, you would have the technology, and the rest would be the storage unit, the cabinet. What does that mean? It would mean a sort of, well, single origin, recycling, dismountable, modular system. Say your family is growing and you need more cooling space, then you can use more without having to put a second refrigerator into your cellar. So there's a lot of potential. This is only a prototype, but it also has the potential to further develop it, and you see a bigger picture of this. What would that mean for the transfer of business models? And this is something that the discussion will also show, hopefully, if we have time, transferring business models. So we said, in particular, one of the challenges is the lack of information along the chain. And the loop operator would be a chance to solve this problem. A loop operator knowing about the materials flows, the information flows, He'd be responsible for the coordination and create incentives for circular business models. This would also mean that communication between the merchant, the dealer, and the manufacturer would also be easier. So the information streams aren't as they should be here either. So translated by Hansen et al., this would look as follows. The loop operator would come in these different systems and have his particular role there. Now, just one other point. Where are we at present when it comes to the different R strategies? The focus is very technology-oriented and at the end of life. But what is the challenge? Well, it's specifically the topic of economic availability of the raw materials, what this means for designs, and there is a lack of speculation on totally new business models, as I've just mentioned. So what we would like is a completely new alliance that would bridge different areas, and engineering, the art of engineering that's represented here, connected to the consumers, the users, the craftspeople, and the designers as a format, as was said there are the living labs, for instance, and the real laboratories where the different stakeholders would be able to meet. And from our point of view, this would be urgently needed so that you could work across these company borders. What would these real labs or living labs look like? Well, they would be institutional, they would have new cooperation structures, but they would also have different regulatory framework conditions, because we would have to look at the conflicts we have at present. There are bureaucratic restrictions, why circular economy isn't working yet, why the product design isn't as thought through as it should be. So all this would be addressed, and this communication of know-how would then be made easier. Then the points of discussion, to wrap up my presentation. Design can contribute to negotiate between the different disciplines. The more complex products are, as we saw in a refrigerator example, the more we need to take into account the design. But particularly when it comes to the consumers, we need a guarantee, for instance, via modular design. Long warranties ensure that people get spare parts. This is also an essential challenge. And then overcoming restrictions by real laboratories and living labs. Thank you very much for your attention, and I'm looking forward to the discussion.